In this video, we're going to solve quadratic equations. This is going to build on those factoring skills that we've been working on. If you want to go back and look at some of those factoring videos, I'll link those in the description. But here we start with the zero product property. This is one property that we will use a lot, and it's thinking about a product or a multiplication of things. So say I have two things that are multiplied together. Let's think about if I had 5 times x equals 0. Automatically, we know that x would have to be 0 because 5 times 0 would be 0. And if I had something like y times 7 equals 0, we're in the same scenarios. Something times 7 equals 0, that means that the y would have to be 0. But what if we had the product x times y equals 0? These are two unknowns, and the only way that a product would equal 0 is if one of those factors is equal to 0. And this applies if you had even more than one factor. So if I had a times b times c equals 0, the zero product property states that at least one of these factors must equal 0. So we're going to use that property in solving equations. If something's already in factored form, we have a product of things. We have x plus 3 times x minus 7, and it's equal to 0. So one of those components must be what's making this equal to 0. So I would set each factor equal to 0. X plus 3 would equal 0 if x is equal to negative 3. And then x minus 7 would equal 0 if x was equal to positive 7. These are the two solutions to this equation because we have a product equal to 0. But when I look at the first example, this is not already in factored form. We want to take this quadratic expression and factor it so that we do have a product of two things equal to 0. So I take that x squared minus 3x minus 4 and write it in factored form. Use those factoring skills that we've been working on and whatever method makes sense to you. All right, but x minus 4 times x plus 1 is the factorization of that quadratic expression. So now that I have it in factored form, we would take each factor and set it equal to 0. That means that x is equal to 4 or negative 1. And we get two solutions. When I have a quadratic equation, we want to get it equal to 0 because of this property. So looking at number 2, it's not currently already equal to 0. Factoring is usually easier when your quadratic term, your x squared term, is positive. So I could get this equal to 0 by moving this to the other side, and that would just be adding x squared to both sides. And that makes that 0 equals x squared plus 7x plus 12. And we go ahead and factor that quadratic. If you want to pause the video and try your factoring skills, you can. We get x times x is x squared. A 3 and a 4 would multiply to give me 12. They also combine on the inside and outside to give me 7x. So our factorization, x plus 3, x plus 4. All right, x plus 3 is equal to 0, and x plus 4 is equal to 0. So x is equal to negative 3 and negative 4. We take each quadratic expression and solve it in this format if it can factor. So looking at number 3, this is still not set equal to 0, and I can move this 2x squared to the left side, but if I do, I'd be subtracting 2x squared, so it would become a negative 2x squared. I love that you can probably hear my dog eating and drinking her water right now. But since this would move that over and become negative, that makes factoring a little bit harder. So I'm going to move the other terms to the right side, and that would make this 2x squared plus 9x and minus 35. Now we take that and factor it. Again, this is one of those factoring where a is more than 1. Whatever factorization method makes sense to you, go ahead and use that. So I use the guess and check method, but this would end up being a positive 7 and a negative 5, because that would be a negative 5x, and a positive 14x, which does combine to give you 9x. We set each factor equal to 0. So 2x minus 5 equals 0. X plus 7 equals 0. One common thing that I see students do is just try to take the opposite sign and say, oh, x is negative 7, which is true, but what we're doing is solving this equation, x plus 7 equals 0. So I'd subtract 7, 0 minus 7 is negative 7. That's why this works out this way. Same thing here, we're solving this equation. So I'd add the 5 over, which makes this 2x equals 5, divide by 2, so x is 5 halves. We're not guaranteed that we get exactly nice numbers, but a fraction isn't necessarily an ugly number. All right, let's skip down to number 4. It looks a little different because we only have 2 parts to it, but we're still going to factor it using our factoring skills. I want to get it equal to 0 before I do anything though. So that makes this 3x squared minus 12x equals 0. This doesn't look like a regular factoring problem because it's not a trinomial. But my first rule of factoring has always been looking for a GCF. And there is a GCF between these two terms. It's 3x. So if I factor out 3x, this leaves me with x minus 4. This is still a product of two things. We have something like x times y equals 0. That just happens to be 3x times x minus 4. So this means when I set each factor equal to 0, I'm going to have 3x equals 0. Divide by 3 still makes this x equals 0. Move the 4 over and I get x equals 4. So we have two solutions. One of them is when x is 0. The other is when x is 4. Checking out number 5, it's still a product, something times something, but it's not equal to 0. We cannot use the 0 product property right now. We can only use the 0 product property if the product is equal to 0. So since I can't set it equal to 0, we actually want to redistribute this out. We're going to expand x plus 2 times x minus 4. We'll distribute, which makes x squared minus 4x plus 2x minus 8 equals 27. This is a quadratic equation. We have an x squared term, and we want to get quadratic equations equal to 0. So that means let's move that 27 to the other side. I could also combine like terms right here for negative 4x and 2x to get negative 2x. If I subtract 27, I get minus or negative 35. Now it's finally equal to 0. We just need to use those factoring skills. And we're going to factor that trinomial. X squared came from x times x. 35 factors of 35 are 7 and 5. And this does combine to give me a negative 2x if we had negative 7x and a positive 5x. So now we have a product equal to 0. We can set the factors equal to 0. And our solutions would then be x equals 7 and x equals negative 5. Remember, there's a way that you can check your solutions for most equations. You just plug it back into the original. See if it satisfies it. If I plug this back in, I get 7 plus 2, which is 9, and 7 minus 4, which is 3. 9 times 3 is 27, so I know 7 works. We can also do that with negative 5. Negative 5 plus 2 is negative 3, and negative 5 minus 4 is negative 9. And negative 3 times a negative 9 is 27, so that does check out. And our last example here for number 6, again, is not already equal to 0. We do have a product, but it's not equal to 0. So we're going to expand this out a little bit first. We have 2x times 2x, which will be 4x squared. We also have 2x times the negative 7. So that's negative 14x equals negative 12. We take that equation and now get it equal to 0. So I can move that 12 to the left side by adding 12. It would say 4x squared minus 14x plus 12 is equal to 0. Again, we're using those factoring skills. I have this time something bigger than 1x squared. We have a 4x squared. But my first rule of factoring is always to look for a GCF. So look at those three terms and see, is there a greatest common factor between all three parts? And it might be 2. 2 can divide evenly into 4x squared, 14x, and 12. So I'm going to bring that 2 out. That leaves me with 2 times 2x squared to get the 4x squared, 2 times a negative 7x to get that negative 14x, and a positive 6 to get the 12. Now we're one step closer to it being in factored form. We do want to keep that 2 out there, and then we continue. So I'm going to factor this time 2x squared minus 7x plus 6. This is using whatever method makes sense to you. You could use the AC method if you know the AC method. I'm using guess and check. But I do get 2x minus 1 and x minus 6. All right, negative 1 and negative 6 multiply to give you positive 6. On the inside, I get negative 1x. On the outside, we get negative 12x. That doesn't work to give me 7, so I screwed up. All right, let's try it a different way. If it's not 6 and 1, what could it be? Well, it's actually 2 and 3. Guess and check is usually one that kind of takes a little bit longer. So I've got 3x here and 4x, a negative 3x and negative 4x does factor. So this did give me what I needed. I needed 2 times 2x minus 3 and x minus 2. I'm going to set each factor equal to 0, but that 2 is the greatest common factor. It doesn't have a variable with it, and 2 can't be 0 because 2 is 2. But 2x minus 3 could equal 0. And x minus 2 could equal 0. So we solve this equation, 2x equals 3, and x equals 3/2. We get a fraction, that's fine. X equals 2. There's our other solution. You can practice some more of these in the lab manual if you would like to.